All right, we're live, so whenever you guys are ready, just let me know.
I was born ready for this moment.
Oh, my goodness.
I figured if he's listening, maybe extra credit wouldn't help. I mean, wouldn't hurt. Now I ruined it.
Yes, yes, you did.
So does everybody have everything all opened up?
I'm good to go.
Yeah, I'm ready.
Yeah.
Cool. So we'll start at question 3 then. Given the linear regression equation, y equals 2 plus 1.5x, what is the y-intercept? And I have 2.0.
Yep.
Likewise.
Question 4, given the linear regression, y equals same equation, what is the slope? And I have 1.5.
Yep, I got the same one.
All right, so given the linear regression, we have now y equals -3 plus 0.25x. What is the predicted value of y when x equals 16? So 0.25 times 16 is 4. -3 plus 4 is 1.
Mm-hmm.
Correct.
All right, then this next one is the Excel sheet.
I want to see if you guys get the same image that I got for the scatter chart.
What does yours look like?
I don't know. It doesn't resemble a hot dog, a hamburger, or a banana. It's got a big fat end on the back, on the lower side, and then it's narrower up on the top. But
yeah, I put hot dog because it's not like curved like a banana, but it's not like
it's not completely round.
Horizontal. Yeah, it's not all kinds of crazy like a hamburger would be.
Yeah, I'd say mine looked hot dog-esque.
Here, you know what? That's not what I want to do. Let me take a look at my screen. That's what I've got. I want to see if that's what you guys represent.
Let's see. Yep, I got the same one.
All right. Then I'm going to stop my...
So we got a hot dog. And then question 7, based on the shape of the scattered plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? I would say the first one, simple linear regression, is appropriate for this data.
Yeah, I put the same thing.
Yeah. Better than the others.
Yeah. Because you can do it with the hot dog shaped one, but not with a hamburger or banana, basically.
Yep.
So, question 8, how many observations are in the data? Is it just asking how many, like, people did they observe or whatever?
That's what I would think. I couldn't really figure that one out.
Like, are they just looking for the sample size or whatever, like the N? Which, I mean,
I think so.
That's 139, but
That's the only thing I could think of what it could be.
okay. I mean, yeah, 139, I guess. That's what they're asking. So what did you get for the y-intercept?
the y-intercept is 1.296. Is that what everybody else shows?
For the y-intercept?
Yeah.
You got what?
1.296. It's on the spreadsheet.
I got 18.69.
Yeah, I think it's
Yeah, so did I.
8.69.
Yeah.
All right. Why is my spreadsheet coming back different then?
I think you have your data flipped, your X and Y.
That might be it.
All right. Well, hang on. I'll see why it would have done that. But stand by one. So where did it say that the score had to be the Y and
I think, let's see. I read on the side in the little explanation, it says the exam consisted of 30 multiple choice problems with a total of 100 points. Student scores out of 100 points are given in the variable scores. So the score out of 100 is the variable one, the one that can change or whatever.
Oh, I see it there. Okay. So then 18.690. And then the slope is 12.695.
Yep.
And predicted is 69.469.
What was that again?
For question 11, what's the predicted value of y when x equals 4? 69.469.
Yeah, that's what I got.
Hold on here. Because I don't know why. I must have done some weird rounding because I have 69.470.
Did you do it in the applet or did you do it on the spreadsheet?
I am trying to remember here. Let me.
And the homework, it even says, be sure to use the spreadsheet. Don't use anything else.
Don't calculate it by hand or whatever.
Yeah.
Correct. we ready for number 12? Oh, wait, no, Michael's.
Okay. Yep, no, you guys are right. I must have done it by hand or something. Okay, go ahead.
So the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What's the maximum predicted value of y for these values of x? Round to 3 decimals. Hint, because there's a positive correlation, we can use the largest x value to find the largest predicted value of y. The largest x value in the data is 6.
Yeah.
Which means the predicted value will be 94.859.
Yeah.
So where are you guys getting that?
Yeah.
From the data.
So you can only have 1 through 6, and 6 is the highest.
But if
So
you look
plug
at even
6 in for x.
Even if you look at all of the variables that they've given for the x variable, and they range, the lowest one is somewhere around, just a quick scan, 1.5 or so, but the highest is actually a 6. So the maximum possible score that was given predicted is a 6. So by plugging 6 into the x column, we get the predicted value of 94.859.
Okay, I think I get that now.
And I have no idea what 13 is asking.
I'm guessing just 1. Like I'm not sure what 13 and 14 are, but I just put 1 for them because I haven't heard anything otherwise. So.
Well, because there's only one, like independent or whatever, is like one of them's the x variable and one of them's the y variable. So there's only one of each, right?
Yeah.
Yeah.
So can we jump back to number 12 really quick?
Yeah.
So on the spreadsheet, there's a section over like the predicted value of 94.859 or whatever. If we go all the way to the end of that row, there's also a prediction interval for y. And is it asking with the largest predicted value of y? Would that be 117.445?
Oh, I see what you're saying. So, because the question is, what's the maximum predicted value of y for these values of x? So, yeah, the predicted is 94, but the maximum I do see is kind of like your lower and your upper, and 117.445.
Yeah.
That does make good sense, and I didn't see that.
Okay, so do we think that's it then? I guess we'll find out.
Question 15. So in this case, the measurement they collect include hat size, circumference of the hat size, length of major and minor axis. What's the response variable? The response variable is the variable that's being predicted, which is the hat size.
Yeah.
So A.
Yeah, really quick before anybody submits it, because I already did. Number 12 is still wrong. It is not 117.445.
Okay.
So does somebody want to try something else?
Wait, was 94.859 wrong?
I didn't try that one. I was just looking at 12 for a long time, and I might have overthought a lot of it. So I don't know what.
I think we should go with our first answer and see if it.
Okay. Somebody want to try that one out for us?
Yeah, I'll submit it. All right, I got 100.
So it is that?
I'll just put down the 94.859.
And what was it again? 94 point what?
859.
4.859.
Okay.
Which is the predicted value.
Yep.
Do any of you know why that is, or?
Well, it's asking for the maximum predicted value, not for the predicted interval. So.
Okay, yeah, I guess that makes more sense now.
And the homework is only the homework quiz. If you haven't taken, it's only 10 questions. They're not hard.
Yeah.
Okay, so has anyone looked at the group project at all?
Sort of.
Yeah, the make inference, take action instructions.
Mm-hmm.
So.
So who was there a certain person that was going to do the make inference and take action on this one? Like, was that somebody's assignment thing?
Well, it's all of our assignments to come up with it, but in the design the study, we had Michael had been the one that was given this particular write-up.
Yeah. Okay.
Yeah, I think in the thing it says one person's the author, and then the
But
other
we all help.
they need to submit it to their group, and then the group needs to review it, sort of thing. So.
So from a make inferences standpoint, we're saying, okay, what are some of the generalized information that we can state about the data? %70 of those surveyed prefer PC over Mac. That would be a generalized statement that summarizes the data.
Mm-hmm.
I'm just trying to figure out how what they're asking is. I mean, what they're asking is basically what I wrote up in the last thing. So.
Yeah, so this write-up doesn't really look all that hard. It looks like we just plug in a bunch of the info into the spreadsheet, and we basically write about what happened, what we thought was going to happen, and what we're doing about it. At least that's what I got from it.
Yeah. And
And he said it has to be 2 pages.
we have most of the information.
I thought it said 2 paragraphs.
No, it said no more than 2 pages. So
Oh.
I thought he said it like had to be 2 pages. I'm like, how are you gonna?
And it says no more than 2 pages, so it says 1 to 2 paragraphs discussing whether your data meets or fails.
Got it.
So I think he just doesn't want you to be super long-winded.
Good. I like it when teachers do that.
I mean, like I'm reading over what it wants us to include, like the alpha level and the test statistic and the p-value, and that's all stuff that I wrote up in the first one. And Trey put in the Excel part, so we have all those numbers.
So it's basically just compiling it all and writing like some short, sweet, I guess, review of what we did and what we're doing about it or whatever. That sounds pretty dang simple.
So yeah, I think the only difference with this one says the goal is to determine which action to take in a particular situation. So,
which I think Casey's standpoint would be get rid of Apple.
Am I that transparent?
I don't know. You're a pretty hard book to read when it came to that. So that was my making an inference portion.
I'm a sphinx.
All right. So if we already have like all the information of everything that we need, is it just Michael write a couple paragraphs, send it out to us, we read it, and then we submit it? Is that pretty much all that we have to do?
Well, from a take action standpoint, I think we have to kind of decide what action would we take based on this data. So I think if we get some talking points here and then just go from that, like, and I'm looking at some of the original instructions on taking action where it talked about actions can include many things: launching an internet ad campaign, or expressing a gratitude or not, getting vaccinated or not, etc. So what kind of actions would we take based on the data that we have identified? Like if we were going to, like one action would be if we wanted to design an app for a particular phone, or for, no, well, this isn't phone, that wouldn't work. Because I think if we'd have done phones, then it would have been a completely different.
Well, so since we were trying to figure out if working adults used it more or whatnot, I mean, we didn't really get that exact from our data because we didn't have it broken down very well. But we might want to make an inference that if we were going to be using, making some sort of like workplace software or something like that, we'd want to target it more towards people who use PC.
So the inference is actually something different than taking action. Inference is basically saying, based on the results of the sample, we determined that in general, those people who use computers prefer PC over Mac. That would be an inference.
Yeah, well, I'm saying for the take action part, from our inference or whatever, we would probably say, if you want to target working adults for some sort of, software or something like that, then we would target it towards PC users versus Mac users.
That's precisely it.
Yeah, I like that because it doesn't have to be anything like legitimate. It could just be hypothetical. So if you're going to launch an internet ad campaign, focus that more towards like a PC, saying, hey, more people prefer this over Mac, and these are the new bells and whistles we've added to it or whatever. Like boost the PC side rather than the Mac side.
Well, I mean, we don't have to boost it anymore because it's freaking awesome. So
unbiased opinion, right?
Completely.
Or another situation, let's say you did make a software for like an accounting firm or something like that, or an accounting software and you're trying to decide how much resources to focus on developing it for PC,
I really like that.
developing it for Mac, then you're going to have more people assigned to the PC side than the Mac side.
Quantitative reasoning. Michael, you're a brilliant person.
So just some ideas. I can write it up like that if you guys want.
Oh, I like that one. I think that one's good.
Sounds good.
Yep.
Okay. I will start making a Google Doc.
Sweet.
I'm sitting by my computer on bated breath.
So is the next thing after this, is it just like doing that PowerPoint thing? Is
I
that
think
like
so.
Yeah, I'm pretty sure.
Okay, sweet. Yeah, I'm looking ahead. It is the PowerPoint for next week. Oh, clicking on next week and I see the end of course evaluation. Nice. Oh, and then there's one more week. That's unfortunate.
He just totally shot his whole dude. Yeah, that's
The last week is finals week, right? So
Yeah.
that's going to be a big disappointment.
I know, we'll study for it and then we'll fail it. I mean, get
So-
a C. I mean,
But here's what gives me hope, though. If when you look under your My Grade section, you look at class progress, you can see what's the absolute minimum grade I can get in here right now. Sweet.
that's so true.
cool. Well, I'll get that sent out to you guys, and I'll stop recording here, and we can.
All right, that sounds good to me.
Come on.
Yep, sounds good.
All right, see you guys.
Thanks,
Yeah,
Michael. Thanks, guys.